I'm Bob Riggio. With me is Senior Master Sergeant Al Hall, and we are located at one of the missile silos. We're about 30 feet below ground right now.
Yes.
And first of all, Al, why don't you tell the folks what your specialty was in the Air Force?
My specialty was missile electronics. I was also part of what they call a EMT or electromechanical team. So we were responsible for about 75% of all the work at the actual silo itself.
And what we'd like to do, of course, at News Center 1 is to honor our veterans. You are a veteran, but we've taken this one step further. Not only are we honoring you as a veteran, we're also taking you to your workplace. And as I said, we are in a missile silo, 30 feet below the ground. And one of your specialties, of course, as you said, was electronics, and that included guidance systems.
Yes.
And that's what we're looking at right over here.
That is correct.
So tell us, let's go through a typical workday for you.
A typical workday would be making sure my team member and I get our trucks loaded up properly, get our security guards, then drive out from Ellsworth Air Force Base to, in this particular case, Delta 9, which is about 70 miles away one way. Okay, and then what would happen is that we would then penetrate the site, which means to enter the site, and that takes approximately anywhere from an hour and a half to 2 hours to get in the silo. And so for us to come out, especially my teams and myself, is anything that's electronic, that's critical to the missile performing its job, we would come out and do any replacements or troubleshooting, resolve the problem. We would prep the system to be replaced. I would come out and race the target information in the guidance system. And then another team would come out, a specialized team would come out called missile maintenance teams, and they would actually remove and replace the guidance system.
And this is the guidance system right here.
That
We're
is
looking
correct.
at it right here, and there's a whole bunch of bolts or screws that you'd have to remove.
Exactly. And that makes sure that the guidance system and the reentry vehicle stays together on its flight out.
And you mentioned we have a bunch of panels behind here. I wonder if we could go back and have Al talk about each and every panel. When you were here, how old were you?
I was 19 years old.
19 years old, a 19-year-old kid working on a nuclear missile, making sure this thing, when the keys are turned, that it's launched.
Right.
That's incredible.
Exactly.
So what do we got here, first of all?
This is our power supply group. Basically, it takes the power that's down below the 12 batteries and through what we call a motor generator, a converter. It supplies power to this rack, which in turn this rack distributes to the other racks here. This is what we call the outer zone drawer. The outer zone is the system that's like a radar field on the top side that monitors any intrusions on the top side. Then there's also the inner zone. The inner zone is, if anybody was trying to tunnel underground, they would pick up the alarm and send it to the launch crews. This rack here is what we call the radio rack, and this was the backup. So if something should actually happen at the launch control center, either it's destroyed offline or the underground cables get cut.
Yes.
After a certain period of time, the missile starts listening on a special antenna upstairs. And from 1967 to 1992, we used to have an aircraft that flew around 24 hours a day called the Airborne Launch Control Center or system that could actually launch the missile as a backup. So this particular rack here, called the Status Command Message Processing Group, this takes all the status that's happening on the missile and the site, converts this information into a form that can be understood at the Launch Control Center. This is what we call the programmer group. If you watch TV when they get ready to launch a rocket at Cape Canaveral, they said it's automatic systems. This is the rack for us, it's the automatic systems. This actually does the launch sequence for us when the proper commands are received. Half the code for the actual launch used to be in this box here. The guidance system operates at a different logic level than the equipment here. So this actually translates between the two, the ground equipment and the missile. It allows both sides to talk to each other. It also supplies power. You can see the lights indicator right here. The compute light is on, means it will normally be on, showing that the missile guidance system is running. Programmer group power, this rack here. GNC power, guidance system power is normally lit also. I mentioned to you earlier about just prior to leaving a site, after we do maintenance here, we always press this button here several times to make sure that when the launch crew does their tests, that they get a proper response.
Right. When you're down here, you don't want this missile launched.
Correct. First step after we come downstairs here, before we do any maintenance on this, we take our key, we put our key in here, and then actually safe the missile itself. There we go.
So once that key is in there, that missile cannot be launched.
Correct.
Even though launch control wants to launch it,
Right.
it won't launch.
Right. You'll see an S in the window right here, means it's safe. And as long as that S stays there with this key in there, it'll be fine. And then last step, before we leave the silo, after all the equipment is taken out, then I will go ahead and put my key back in and take the safety key out.
How long does it take to do a complete inspection?
It varies, but normally it's, I would say, within 45 minutes.
Al, you have a 90-ton door sitting over the top of the missile.
Correct.
And you have to remove that door rather quickly,
Yes.
I'm going to assume, because when we're going to launch the missile, that door has to be removed and then the missile
Correct.
will exit the silo.
Yes.
So how do you remove the door?
Well, when the time comes, the capsule crew, the launch crew will then go ahead and initiate a launch. Part of that launch sequence is 2 solid propellant gas cylinders go off and pulls this piston assembly down. When this piston assembly comes down, the first thing that's going to move is the lock pin, and then after the lock pin is pulled down, the rest of the pressure is on these 2 cables here, which are connected to the bottom of the launcher closure, and that will pull the door open.
Just pull it open.
Right.
In seconds, I would assume.
Seconds, yes. About 3 seconds. The public, is depending on us to do our job properly. The line still goes on because we have young men and women still out today doing exactly what I was doing. We don't stop work till it's minus 50 degrees below zero. If the missile's off alert, then it's our job to get it back up on alert.
To me, it's just all of these racks and the missile itself, the guidance system is just incredibly complicated. Everything had to work. And you were inspected constantly, I would assume.
I wouldn't say constantly, but we know we're under any time for an inspection. So we're out here doing maintenance. Our quality assurance can come out anytime and then basically watch the task. We never know if they're going to show up or not, but that keeps us on our toes too.
When you leave a silo, how confident are you that that missile's going to work?
I'm 99.9% confident.
That's pretty good.
Yes.
No, this is incredible. This is an incredible experience. So thank you very much for taking the time to talk to us about this.
My pleasure.